The cosmos, what is known as the universe also, is all there is or was or ever will be. The universe is not just, the planets, the galaxies, the stars. It's also us. We are part of the universe. We are actually a way for the universe to understand itself, because everything that we are was once dead stars that blew up and came together to make the blood running through your veins right now. We'll get back into that later. So, the universe is everything. And what we're going to talk about today is what is the universe, what is our cosmic address, like where are we, what everything is made of, the smallest components of what makes us, where everything started, the formation of the elements, the formation of the solar system, and some mysteries that we don't know. Yeah. This is the definition on Wikipedia. The universe is all time and space and its contents. It includes planets, stars, galaxies, the contents of intergalactic space, meaning everything in between, all that stuff, and the small subatomic particles, your atoms, molecules that make up everything, and all matter and energy. Matter is just stuff you can touch. And energy, energy. So the solar system. This is, how we like to show what it looks like, but it actually doesn't look like that. This is kind of a representation, a pretty way of explaining it. Here's the sun, it's gigantic. And then we have our 4 rocky planets, Mercury, Venus, Earth, and Mars. The asteroid belt. Then we have Jupiter, the biggest planet. Saturn, what they call the jewel of our solar system, because it has these beautiful rings. Uranus and Neptune, which I don't know that much about, so I won't talk about that much. Pluto, which is not a planet, get over it. And, and the Kuiper belt, where comets come from. There's also Ceres, which is the biggest asteroid, which is smaller than our moon, but we have a robot around it right now, taking a look at it. I'll show you that in a second. So here's a better representation of the solar system. You have these 4 little bitty rocky planets really close together, and then you have these gigantic gas planets. They're mostly just made of gas, and they're really far apart. And Mercury, the first planet of the solar system, it looks kind of like our moon,
The hottest?
It is the hottest. But, no, actually, it's not the hottest. It doesn't have an atmosphere. Venus is the hottest because it traps all the heat that comes in. Heat comes in and it doesn't go out. We'll get into that in a second. There's actually ice on Mercury? It's so close to the sun, how could there be ice? Because there's a crater on top. Y'all know what a crater is, right?
Yeah. No.
There's one outside of town, right?
It's a meteor.
Yeah, a meteor, a rock from outer space came and made a big hole in the ground. And so that's what all these little holes are. And so a meteor came from the top, and there's this one part on the poles, on the top of the planet, that's completely shaded. And a comet came, dropped off some water, and it's frozen. Even though it's right next to the sun, there's still a little bit of ice. We just learned that like a couple years ago. Venus has this really thick atmosphere. It has what's called a runaway greenhouse effect. We have a greenhouse effect, and partially it's good because when it's dark at night, we don't freeze to death. But it got out of hand. Too much stuff got in the atmosphere, keeping the heat from leaving. And that's what we're doing right now. We're putting a little too much gas in the atmosphere, and it's kind of keeping the heat from leaving. But that's another subject. This is what it looks like when it's in between us and the sun. It's like a little eclipse. We can see it in a telescope. It'll be blocking the sun. The Russians in the 70s or something sent a robot down, and it took a picture of the surface. It snows metal. It's so hot that it's melted, and then it became rain and then snowed. And then, just like the moon, when we see it from a different angle, it's covered up in its shadow. On Venus, it snows metal and rains sulfuric acid. Not a pleasant place to be, at least on the surface. When we're looking at it from Earth, the sun is barely setting, and here's Mercury, and here's Venus, and Saturn's further in the distance. But if you want to find Venus, look in the morning or in the evening towards the sun, and there it is. It's what they call the morning star. What?
The brightest.
It is the brightest, and it's what we see. A lot of people wonder why their wishes don't come true. It's probably because when they wish upon a star, they're actually wishing upon a planet. So that's why it didn't happen. Dumb joke, sorry. So actually, it's really, it is very hot there on the surface. But NASA has been planning, or has been studying a possibility of us actually visiting it. It's hot on the surface, but as you get closer to space, it becomes cooler. And what they want to do is send a space
station.
Well, kind of. Not like one we have, but one that kind of floats in the sky. So a spaceship comes, a parachute happens, and then like deflates or executes, I don't know. And then a blimp floats in the sky where it's nice and warm, and nice and not too hot, nice and cool, right where it's just right. And here would be some astronauts looking out on the sun setting. Just, you know, a thought. Earth. This is the only planet we know that have life, and no, maybe Mars does. We'll find out. Maybe in y'all's lifetime. Maybe one of y'all could be one of the first person to step on Mars. Let's see. So this is Earth as seen from the moon. This is an eclipse seen from space. An eclipse is when the moon covers the sun, and here's the shadow of the moon, and on the surface of the Earth. Who's heard of the Northern Lights?
Yeah. Yeah.
Nice. Heck yeah. This is Northern Lights seen from the ground, and this is the Northern Lights seen from space. The Earth is not the only place where the Northern Lights happen. We'll see that later. This is Earth as seen from Saturn, way out there. You can still see it. It's what's called, what Carl Sagan, check him out if you haven't, has called the pale blue dot. This is a pale red dot, but seen from outer space. You know, Earth is just this little bitty dot, and all of our problems, all the bad things we do, and all the good things that have happened, it seems so insignificant because it's all just this little bitty dot, and it shows how important it is to take care of this planet because there's only one Earth. And here's Mars. It's the next planet. Here you can see the atmosphere. There's a lot of dust. There's a dust storm going on. This picture was actually taken by an Indian satellite, and the Indian government sent a probe out there. Here's some Indian language. And it has hardly any atmosphere, only 1%. Y'all know percentages, right?
Yeah.
Yeah. It only has 1% of the atmosphere we have. So if we were to go, we would have to take all of our air with us. When we go. This is a sunset from Mars. If you'll notice, the sun is way smaller.
And it's blue.
Well, actually, the sky is blue here on Earth, but on Mars, the sky is kind of,
Dark.
yeah, it's more red, orangish. This is a black and white photo, so you can't really see. But yeah, it's further away, so the sun is smaller from there. Here's the poles. You know how in the North Pole and the South Pole, there's a lot of ice on Earth. There's a lot of ice there too. But it's
like
not.
ice cream.
Yeah, it is like ice cream. Except you don't want to eat it because it's carbon dioxide. Carbon dioxide is what we breathe out. We breathe in oxygen. It's what, you know. Everybody breathe in. Oxygen. And then out. Carbon dioxide. So this is ice carbon dioxide, which maybe we can use to
Ice cream back.
if we want, you know. Why not? And here's a crater.
Ice cream.
I mean, I don't know if there's any ice cream there. I haven't been there, so I can't tell you. There's a lot of sand, so it comes in. I could only fit half on the slide, so I figured, whatever. A lot of features on Mars look a lot like features on Earth. This could be, you know, in Saudi Arabia or something. Except here's some ice, some carbon dioxide ice. But yeah, they have sandstorms just like we have here. And here is the Curiosity rover. This is what is on Mars right now, scoping the scene, helping us see what it looks like. And doesn't this look like it could be New Mexico, kind of?
Yeah.
Yeah.
More like a desert.
It is, the really dry part of New Mexico. You know, it looks a lot like Earth, which is why it's the first place we want to go.
Let's go then. Just in case.
Yeah, just in case, because the dinosaurs didn't have a space program, and so they couldn't stop the asteroid that came and killed them all. We do. And so, I don't know, just in case something happens and all life on Earth ends, at least we have another place to go. Mars also has canyons. Who knows how canyons are formed? Water, exactly. So we know that in the past, there was water on Mars. There just isn't anymore. It dried up. We don't know why. That's why we're trying to find out. Here's another canyon on Mars. As you can see, you know, this is where a river was, and that's how it formed.
It looks like a little, like a vein.
Yeah, it does, like a vein or tree roots, yeah. This is the asteroid belt. Guess what?
What?
I just lied to all of you. That's the Grand Canyon. But you thought it was on Mars.
No, I didn't.
Alright, well, I hope that fooled somebody. Because it looks a lot like this. I kind of just want to illustrate that, yeah, rivers form canyons, This is one on Mars. This is the Grand Canyon. See the similarity? Okay, I won't let
I
you
don't
get
get it.
Water eats rock, makes a canyon. Here's the asteroid belt. This is what did used to be planets. As Jupiter rotates, asteroids follow it as it goes around. It's just rocks, as we would see here on Earth. You could walk by and you would see an asteroid that fell on Earth, and you wouldn't even know that it was a different rock because it looks so much like a rock here. Yeah, actually, here's one. There's an asteroid that fell down on the planet.
It can cost many, like hundreds of dollars for just a little rock.
It's true. They're really cool. A friend of mine has a piece of a meteorite on his wedding ring. It's pretty cool. So this is Ceres. It's the biggest asteroid. It's so big that it got to be spherical, like a ball. Here's it's compared to the moon in its size, and we know that it has a lot of water on there. In fact, some of this water we don't know. Actually, we're still studying this. This is the shining spot on Ceres. We don't know what it is. It's shiny and it's reflective.
It's
Could
cold.
Yeah, it is cold. It could be snow. It could be gas. We don't know. So here I have Jupiter. It's the biggest planet, and if you're looking at it, from the ground, here would be the moon. It's in a different place every day or every night.
How much moons does it have?
A lot of moons, and I'll show you in a second. It has rings. You can't see them, easily. This is looking from behind with the sun in the background. And if you look at it in a telescope at night, you can look at the red spot. You can look at it right before you go to bed. It'll be here, and right before the sun comes up, you can take another look at it, and it'll be there. So even though it's the biggest planet, it spins the fastest, and it has a lot of moons, crazy moons. Here's Io. It has more volcanoes than any place in the solar system. Here you see an explosion, and here's Europa. It has a lot of water underneath. Here's what they think it looks like underneath. And here's some geysers, like Old Faithful?
Yeah.
Spews out water, just like here. Because it's being tugged in every which way by Jupiter's massive gravity. Here's Ganymede and Callisto. Other interesting moons we'll learn more about in the coming years. This is Saturn. It's what they call the jewel of our solar system because it looks so cool with its rings. Here's looking from behind with the sun on the other side. And here is a storm happening on it.
What's that blue spot?
What's
Blue
that?
spot. The blue spot.
Oh, glad you mentioned that. These are its northern lights. Here is this crazy storm that happens on the poles. It's shaped like a hexagon. Y'all know what a hexagon is, right?
Yeah.
How many
Kind of
sides?
looks like a
Exactly. Yes.
It looks like a hurricane. Kind
It is. It's a hurricane that's always happening. And here is looking at its rings with a moon that's covered up on the other side. And Titan is a moon in the orbit around Saturn. It's really cool. It has an atmosphere just like the Earth does. It has rivers and lakes just like Earth does. Yeah, I'll show you a picture in a second. This is Enceladus. Underneath it has water, and it's always spewing out because it's tugged in every which way by Saturn. And so say if you had some water in your mouth and everyone was squeezing you, you would spit it out. So that's like what Enceladus does. It has other moons, but this is the most interesting. This is an image we have from the surface of Titan. We sent a robot. On its way down, it saw the rivers of the planet, of the moon. Here's Uranus. It's has rings. Neptune. What is everything made of? Atoms. Exactly. Y'all heard of them, right? Y'all know what atoms are made of?
Yeah.
What are the three parts of them?
Electrons, protons, and neutrons.
Here's carbon. It has 6 protons, neutrons, and electrons. Here's hydrogen. It just has 1. Here's iron that has a lot more. So we'll find out how they're made. How are atoms made?
Matter.
Exactly. Well, they are matter, but how does that come about? So here's a periodic table of elements. Y'all seen this before?
Yeah.
Awesome. So you know that it starts out with 1 proton, and then on the other side it has 2, and then as you go down it has more protons. And so how did that happen? Well, when the universe was formed, it was just hydrogen. But all that hydrogen came together. They squeezed, like 1 and 1 squeezed together and made 2. And that's what's happening on the sun right now as we speak. I'll get more of that later. So if you look at some old milk, just some milk, you'll see that it has some elements on it,
Vitamins.
like sodium, bam, calcium, bam, iron, bam.
Iron.
Yeah,
Where's iron?
exactly.
We
You look at it, it's
need
like,
the iron.
yeah, we need iron. It's weird though. You look at iron, it's a metal. It's like, how could I be eating that? but it's just a little bitty bit, and it's in a different form that you can eat. So yeah. But my point is, everything, even milk, even you and me, the ground, everything is made of these elements. There's nothing that isn't one of these. How does those elements form? If everything started out as hydrogen, how did it get to be something else? In the middle of stars. How does the sun make energy, and how does it make helium out of hydrogen? Y'all know what gravity is, right?
Yeah.
It's what's always pulling us to the ground. So the bigger the object, the more the gravity. The sun is huge, so it has a lot of gravity. And it's like a hydrogen bomb happening all the time. So it's exploding, but gravity's pulling it back in. And all that pressure, meaning the gravity, is what squeezes hydrogen to make helium. So if you look at all the colors of all the stars in the entire universe, of what we can see, they kind of follow a little pattern. And we can look at their color and how big we can tell they are. And they all kind of follow this sequence, as we call it. Here's color, and here's how bright it is. And we can see patterns of different kinds of stars. White dwarfs, the sun, the super big stars. So the sun is an average star. There's some stars that are really, really big. Like this is the orbit of Earth right here. Right here. So this is the little bitty sun, and this is a giant star. So this star helps make elements. There's regular stars like our sun, which has this kind of life cycle, and they live longer, and they make lesser elements like carbon, iron. These are the high mass stars. They live fast and die young, and then they go supernova, and here's a star blowing up. This is a supernova. This is what gives us their goods, and then made these big clouds of dust. These big clouds of dust then turn into little baby stars. And then there's galaxies. Galaxies are just collections of stars. By the way, do you know that there's more stars in the galaxy than there are grains of sand on all the beaches on Earth? Yeah, it's a lot of stars. Different galaxies will have different shapes, and here's some of them. Here's the pinwheel galaxy. It has that kind of shape. And here's a barred spiral galaxy, which is kind of like that, right? Here's our galaxy, the Milky Way. And you go really far out in the city, and it's really dark in the sky, you can actually see the Milky Way, what it looks like. And so, just to review our cosmic address, this is where we are right now. Earth, and then within the Earth, we have the solar system. We have all of our neighboring stars. When we see them in the sky, we just see, different, it looks like there's different dots on a plate or something, or in glass. But actually, they're all over the place. It's they're in three-dimensional space. They're all floating around at different distances from us.
I can't see Earth.
Oh, because it's too small. Yeah, get used to that. You're not seeing Earth.
It's right there.
Here's the sun, and so Earth will be little tiny right here.
Oh dang.
Yeah. We're going out really far. Do y'all know what a light year is?
Yeah.
Buzz Lightyear.
Buzz Lightyear.
You go faster than the speed of light.
Well, nothing can go faster than the speed of light. That is the cosmic speed limit.
But isn't a black hole faster than the speed of light if you can attract light?
No, it takes the light and keeps the light from going any speed. So, who knows how long it takes for the sun's light to get to the Earth?
Seconds. I meant like
8 minutes. And so the Earth is 8 light minutes from the sun. And so, so a light year is just how long it takes for light to travel a year. And so this is several light years. The closest star, Proxima Centauri, is actually 4 light years away. So even if we could go the speed of light, and nothing in the universe can except for light, it would take us 4 years. So we have to be clever. So after our nearest stars, here's the Milky Way galaxy. All the stars we can see in the sky are a little bitty circle within the Milky Way galaxy.
that's only our galaxy.
That's only our galaxy, and there's so many. Here we have the local group. These are the other galaxies that are in our neighborhood. And then we have the Virgo supercluster, which is the different clumps of galaxies in our neighborhood.
Wow.
And then we have, even bigger, all the other superclusters in our neighborhood.
Well, I can't even see ours.
No, we're so small. Here's a little bitty like collection of galaxies right there. And then everything that we know exists.
Oh.
Yeah.
Whoa.
All the observable universe, what we call the cosmic horizon. Because you know when you're on the, sorry, what? Well, we don't know if it's infinite, but all we know is we can only see 14 billion light years away. But there may be more. It's kind of like when you're on the shore, you see a boat going out over the horizon. And you know that there could be more beyond the horizon, but all you can see is that boat. And it looks like it disappears, but it's just going around the curved surface of the earth. So there may be more, we don't know. Who's heard of the Big Bang? Not the sitcom,
Last year.
not the TV show. I'm glad y'all heard of it. Everything was in one point at one time, then it all blew up. We can see the energy left from the explosion of the Big Bang. We can see that when we look as far as we can. That's what it's showing here. So there's the clouds of dark hydrogen, and gas clouds collapse, and then galaxies form. The further back we look, the more simple galaxies look. They'll just be a blob. But then we see that they get more involved as time goes by. They're little spirals. And this is very important. This is how elements form. They were born in stars, and then they did that. So it made that cloud that then formed our solar system, made our sun. 4.6 billion years ago, the sun was just a cloud floating through space. And then so little clumps came together, and then gravity pulled other clouds and other clumps together. It slowed down, it started to cool down, and then the clumps became planets, dwarf planets, asteroids, comets, moons, what would become us. I wanted to kind of close it with a mystery. Here's everything that we know of. Everything that the stars, the galaxies, you, me, the planets, they're made of atoms, right? This is everything else that exists. We know it's there because we can see its effect on the galaxy. They're moving faster than they should be. Imagine you put a ball up, and then it starts to go 50 miles an hour, and then 100 miles an hour. That doesn't make any sense. That's what's happening right now. The galaxies are moving faster than before, away from each other. We don't know why. Einstein looked at it and he called it anti-gravity, but then he got rid of the idea because he said it didn't make any sense. Well, it doesn't make any sense, but that's what's happening.
What?
Exactly. And we call it dark matter because it's a little different, but we don't really know what it is any more than dark energy. We might as well call it like
Unknown.
unknown 1, unknown 2, Fred and Wilma. We don't know. Yeah, this is a mystery. Nobody knows why it's there. We can see its gravity, but we don't know. We can't touch it. We can't look at it. We don't know what it is. That's one of the great mysteries of the galaxies right now, and hopefully one of y'all discover why that's there. And here are some galaxies. Yeah, little points of light. Any questions?
I'd like a page.